Hi, welcome to a really quick video on formal charges and how to calculate them. So in your lesson, you may see more than one equation to describe how do we calculate formal charges. And just to remind you, formal charges, the main job of formal charges is to sort of keep track of the valence electrons that an atom quote unquote has in a molecule versus how much they started off with. So the valence electrons of the atom itself. So the two equations you may see is something like valence electrons minus number of bonded electrons divided by 2 minus number of unbonded electrons. Or you may see a simpler one where it's valence electrons minus number of bonds minus number of lone pair of electrons. These two equations do the same thing because essentially if you look at a molecule like this, what you're trying to do is figure out how much of the electrons that the atom actually owns in the molecule if the atom were to leave the molecule versus how much they started with. So starting off with nitrogen. Nitrogen has 5 valence electrons. And we know that because if we look on the periodic table, it's in group 15, and group 15 or column 15 has 5 valence electrons. So it has 5, but how much does it have in this molecule? So when we're doing that, we're thinking about this nitrogen leaving that molecule. If the nitrogen were to leave the molecule, it will take all of these unbounded electrons, so the lone pairs and this unpaired electron that are only attached to the nitrogen, it's going to take those with it. But it also has electrons in the bond. Now remember, these electrons are shared between the nitrogen and the oxygen, so it can only take half. So that's why in the equation here it says number of bonded electrons divided by 2. So for the bonds, you have to divide those electrons by 2. So what we would do is if we were looking at the Lewis dot structure where the bonds are shown as dots instead of as lines here, so this nitrogen is going to take all of these electrons with it, right? So if we were to calculate the formal charge of this nitrogen, we would say it's, again, we take the number of valence electrons minus the number of bonded electrons divided by 2 minus the number of unbonded electrons. So the unbonded electrons, let's start with the formal valence electrons. Nitrogen has 5 valence electrons because it's in group 15, so 5 minus. And then the number of electrons, total number of electrons in the bond that's attached to the nitrogen in this molecule will be 1, 2, 3, 4, but we would divide that by 2. So 4 divided by 2 because nitrogen only gets half of those. And then subtract from that the number of unpaired electrons or unbounded electrons on the nitrogen. So that would be 1, 2, 3. These electrons that are not in bonds that are attached to the nitrogen, there are 3 of those. So then when we do the math, we would do 5. 4 divided by 2 is 2 minus 3, giving a formal charge of 0. So that means that this nitrogen has a formal charge of 0. Okay. So if we wanted to do that using the other sort of abbreviated equation, this one here, it would sort of do the same thing. So instead of counting the number of electrons in each bond, right? Instead of saying this is 1, 2, 3, 4 electrons, we would just count the number of bonds, so 1, 2, because that sort of splits it in half. Each bond has 2 electrons, so by just counting the bonds, you're already dividing it by 2. And the other thing with this equation is it says number of lone pair electrons. Well, that would be easy enough for this lone pair. This is a lone pair, but what about this unpaired electron? You have to count that as well. So this full equation is more detailed. It may be a little bit more confusing, but it's more detailed because in the unbonded electron, it includes the number of lone pair electrons and unpaired or single dot electrons like this. Okay. Let's just do one more example, another atom. Let's try to do it for sulfur in this thiocyanate molecule, so that's the chemical form of the molecule. Sulfur is in group 16, so it has 6 valence electrons. All right, so if I were to calculate the formal charge, I would do number of valence electrons minus number of bonded electrons divided by 2, or you can just count the number of bonds, minus the number of unbonded electrons. So the numbers of electrons that are in lone pairs or unpaired electrons directly attached to the sulfur. So sulfur has 6 valence electrons, so we're going to do 6 minus, all right? Now, if sulfur were to leave this molecule, it would take, of course, its lone pairs with it, and it would take half the electrons in the bond, so it'll take all of these, right? Okay, so that would be the number of bonded electrons will be 4 divided by 2, or you can just count 1, 2. Minus the number of unbonded electrons, so the lone pair, so 1, 2, 3, 4. It has 4 lone pair electrons it's going to take with it. Okay. All right, so then in this structure, sulfur would have 6 minus 2 minus 4 would also be 0. Let's try one last example, and let's try it for this nitrogen. So we're going to do the same thing for nitrogen. So for nitrogen, again, the valence electrons are 6. It's in 5 because it's in group 15. So the number of valence electrons here are 5. Number of bonded electrons, again, I could do 1, 2, 3, 4, and then divide that by 2 if I count all electrons in the bond attached to it, or just count the number of bonds, 1, 2. And then the number of unbounded electrons, 1, 2, 3, 4. So when we calculate that, we get 5 minus 2 minus 4 will give us a formal charge of -1. So this nitrogen actually has a formal charge of -1. All right, final note on formal charges. One thing you should know about formal charges is that when you add up the formal charges for all the atoms in the molecule, they should equal the overall charge of the molecule. So this molecule, SCN-, has a -1 charge. That's this chemical formula. It's an ion. The formal charge of the sulfur is 0. We've already calculated that. If you calculate the formal charge for the carbon, it's also 0. So just a quick work on that. Carbon is in group 14, it has 4 valence electrons, minus the electrons that it shares in the bond, so 1, 2, 3, 4, and it has no lone pairs on it, right? So then in this case, the overall formal charge here is 0. Nitrogen has a -1 formal charge, so if you look at all the formal charges, 0 plus -1, it gives you the overall charge when you add them together of the molecule. All right, hope you found this video helpful. Good luck with your studies. Take care.